Here we go. Let's get it started with another fun-filled, action-packed, non-flipped Algebra 2 Classroom video. And we're going to learn two properties of logs today to add on to the three we learned last time. Last time we learned the product property, we learned the quotient property, and we learned the power property. So today we're going to learn two more. And the first one's going to be, you've actually seen this one before if you've been doing notes for me, the inverse property. Yeah, this is going to be the inverse property, yeah. Just like we have inverses for addition, you know, the inverse of addition is subtraction. The inverse of multiplication is division, right? The inverse of squared is square root. We have inverse for something like this as well. You've seen this before, but you probably have forgotten since you didn't really use it after you learned how to use the pattern to find this out. But let's say, for example, we have like this. 3 to the x equals 5, right? And I tell you, solve for x. If I'm asking you to solve for x, what do we need to get rid of here then to get x by itself? The 3. But that 3 is not like, it's not a multiple, it's not multiple of 3. It's not adding 3 or anything. That's a base of 3, right? X is the exponent. I don't want x to be the exponent. How do we get rid of a base of 3? Does anybody remember this? We did do this on the very first day we learned about logarithms. Log what? Log base of 3. Very good. Nice. Second class today to get it right. Log base 3 of 3 to the x. That is going to cancel out that base of 3. This is an example, so if you want to have your example, you know, maybe you want to write it down. If we did the log base of 3 on the left side, then what do we have to do on the right side? Log base 3. So what's going to be? It's going to be log base 3 of what? Of 5. That's right. Right. This is just like a normal thing. If you subtract 3 from both sides, you have to subtract 3 from both sides. Same idea here. We're taking log base 3 of both sides, and then as Trey said, we do this because that's going to cancel out the base of 3. We use log base 3 to cancel out the base of 3. That's because it is an inverse. Okay, inverses cancel each other out. So if that log base 3 cancels out the base of 3, what's left? X. And then we have x equals?
Is that says property or property?
Property. Log x equals log base 3 of 5. And this is just to illustrate the inverse property of logs. Because, yeah, the log base of something is going to cancel out a base of that same number. So the actual property now is going to be... what do you mean? That's the answer, right? And that's showing you how we use the property, right? Because you've seen this before. But I'm going to write down the actual property. But where's my example page, though? All right, so the actual property is going to say if you have log base b, I'm going to use purple so it's easier to see. Log base b of b to the x. What would this equal? No, this is the actual property now. This is the actual property. Look, if you were to replace b with a number like the 3, what happens with this log base b of b? It cancels out, so what's left? Or just x, right? Log base b of b cancels out, and you're left with just x. This is to show you that the log base b will cancel out the b. Okay, and then it also goes in the other direction. For example, if I have... So it can go the other way as well. So if you have, for example, b raised to log base b of x, what do you think this would come out to equal? The b and the log base b, remember they're inverses of each other. They cancel each other out. It would also be x, that's right. All it's saying is that the base with a log base of the same number cancels out completely. If you see some examples right here that we're about to do, then you'll see this is actually a very simple concept. For example, Here are the examples we're going to do. A log base 3 of 3 to the 11. What would this equal? $11, that's right. The log base 3 of 3 cancels out, just leaves you with 11. All right, next example.
So it cancels the log and both these out?
Exactly, because the log base 3 cancels out the base of 3. Brings down the 11. See how 11 is an exponent to start with? It brings it down, so now it's just a number. It's not an exponent anymore. Next example, log base 6 of 6 to the 7. So Adelina, can you tell me the answer for this then?
7.
It's just 7, that's right. Because the log base 6 cancels out the base of 6. Boom, bringing down the 7. And lastly, we got log of 10 to the 8. What would this equal? Why would it be 8 though? Because 10 is the base, right? We don't see the base right there, so it is the unwritten 10, which means that this log base 10 would cancel out the base of 10, leaving me with 8.
What if the numbers were different? Like what if they
Then this property doesn't apply. All right, but you will see some at the very end. We're about to do some more, and then you'll see how sometimes, even when they're different, you can still use this property. All right, but first let's do some more examples. For example, if we have 7 raised to log base 7 of 25. What would this be? 25, that's right. Same thing, still cancels each other out, leaving you with just the 25. And example E, what if we had 2 raised to the log base 2 of 8x? What would this equal? 8x, that's right. Because the 2 log base raised to log base 2 cancel each other out. So this is pretty simple, right? Not too complicated right here. Some would say this is a little bit brainless. However, let's look at 2 examples where you actually do have to use a little bit of thinking here. So example F. It's going to be log base 9 of 3 to the 6th. So what is the problem here? Hang on a second. Right off the bat, right? Can we use the inverse property and cancel things out? No, why not? Right, it's not the same number. The base of the log is 9, and then the base of the number is a 3. However, what would I want this 3 to become if I were trying to use the inverse property? A 9, right? Can you turn 3 into 9 using exponents?
Yes.
How? Right, 3 squared. So this is, I can rewrite this as log base 9 of 3 squared, right? 3 squared. However, look, if you just put a 3 squared here, you change the original 6 to a 2, right? You can't just change numbers randomly. So what exponent would I have to put on the outside here? Not a 6, because then that would come out to be a 12. What exponent should I put? What exponent should I put out here to make sure that it goes back to the original 6? What is the rule about exponents here? You don't add them. That's if you have 2 bases multiplying. It's 3. That's right. It's 3. How did you get 3, Ronnie? Exactly, because 3 times 2 gives you back the 6 that you started with. So now, this is the same thing as our original. We just changed how we wrote it. And why would we do this? Because now look, this log base 9 of, what is 3 squared? 9. So this is actually log base 9 of 9 raised to the, not to the 6, to the 3, right? Because 3 squared is the 9. What's on the outside here? The 3. And so my final answer here is what? 3, that's right.
answer would be a fraction.
It could be, but most likely it wouldn't be, you know. All right, let's look at one more example that looks like this. G log base 8 of 2 to the 12th. Okay, first of all, what would I want my 2 to become if I were trying to cancel it out? 8. I want it to be 8. I want it to be the exact same as the log base, right? Right, because 2 to the 3rd is 8. So we're going to change this to say log base 8 of 2 to the 3rd raised to the, wait, what did you say? 4, that's right. Why did you say 4, Lacey? Exactly, because 3 times 4 gives you back the original 12. You're multiplying there. Okay, so then this is the same thing as log base 8 of what? 8 of 8 raised to the?
No, 4.
Raised to the 4, that's right. Because the 2 cubed is my 8, and then I still have the 4, raised to the 4 on the outside, right? So then my final answer is going to be 4, that's right. And that is how you can use the inverse property. So write this one down, and then we'll go on to the next property.
Which would be cross?
No. Wait, what? All right. This next part is called change of base. This is called change of base. And let me illustrate why this is important for you. So first of all, everybody get out your phone calculator. Get out your phone calculator. And I want you to try to tell me what the answer to this is. Evaluate log base 5 of 29. Can you, on your phone calculator, tell me what this is equal to? And if not, tell me why not. Hang on. I gotta. This is scripted. All right. So yeah, Lacey, you said you're having trouble finding the answer because why?
It says log 10 on the calculator.
Right. Your calculator only has log base of 10, but what is the base that I'm asking you to find?
5.
5. Right. So that is why this is going to be important, because you see on a calculator, also on your computers, you can't type in the log base of 5, right? So you're like, okay, I can't even find the answer then unless I have a fancy school calculator or I use Google and write the question or use Wolfram Alpha. But this is why it's important. Change of base says that if you have log base b of x, you know, b and x can be any number. In our case, right, b is 5 and x is 29, right?
Yeah.
This is the same thing as log of x over log of b. And it's actually called change of base because you see how I wrote log of x over log of b, right? The only thing that matters is that the base is the same. I could pick any base. I could put log base 2 of x over log base 2 of b. I could pick log base 137 of x over log base 137 of b. Same answer. But I just wrote log of x and log of b because that's simple, right? That's on your calculator. Because when I write log of x, what's the base there? What's the base right here on the log of x? 10. That's right. You don't see it, so it's 10. So if I'm trying to use change of base to find an answer, what would it be? This log base 5 of 29 is the same thing as writing what? Log of 29? That's right. Log of 29 over log of 5. These are the same thing. And now with your calculator on your phone, you can find log of 29 over log of 5. So can somebody put down your calculator and tell me about what you get in 2 decimal spots? Try it out. Okay, so now that you got the answer, remember Apple users, you gotta type in the number and then press log first. So it's like, and then press log. It's opposite order. So, okay, what was the answer? 2.09. That's right. This answer should come out to be around 2.09. So let's just do a few more examples to make sure that we can get the right answer with our change of base. What? The squiggly line just means it's about, because you're rounding, right? It's not actually 2.09 exactly, but it's about 2.09. All right, so I'm going to write the directions for these next set of problems so you have some examples to look at. Round the following logs to the nearest hundredth using change of base. This is change of base, what we just did. Okay, so the first one we're going to do is going to be log base 2 of 128. So if I use change of base, what is this equal to? It's the same thing as what?
Log of 28 over log of 2.
Right, log of 128 over log of 2. And can somebody in your calculator tell me what this would come out to be? This comes out to be an exact answer, by the way. 7. All right, you're okay, it's 7. That's right. I was like, who said that so fast? All right, 7. So this one should come out to be 7. That's right. All right, let's try another one. In a regular, so in these fancy school calculators, right, you can literally type in the base and the final number, right? But not everybody has these kind of calculators at home, right? Okay, so let's do log base 8 of 16. This is the same as writing what?
Log of 16
Log of 16
over log of 8.
over log of 8, that's right.
Does it matter if someone's on top or someone's on bottom?
Yes, it does matter because this is saying log of 16 divided by log of 8, right? Is different. Okay, so I want you to find the answer to this and round to 2 decimal spots. See ya. Round it to 2 decimal spots. What would you get? 1.3. How do you round? It's 1.33 because the next number was a 3, right? That's below 5, so you just keep it at the same. When it's 5 or higher, then you raise the number 1. 1.33 is the answer.
Oh, that's the answer?
That's the answer, yes. Because we're rounding to 2 decimal spots. If it was like this, 1.335, you see how it's 5? The 5 tells you to round it to 1.34, right? If it's 5 or above. That's true. You are gonna fail science if you can't round like this. C, last one. Log base 5 of 225. This is the same as what?
Log of 225 over log base of 5.
Log of 225 over log of 5. Not base of 5, just log of 5. Yeah. And can somebody tell me what they get? What does this round out to? 2 decimal spots. Wait, what? 3.37 is the correct rounding and everything. Very good. Nice. Pay attention to how many decimals it says. It says round to the nearest hundredth. What's the easy way to tell how many decimal spots you should have? It says hundredth, right? How many zeros does 100 have in it? 2, so 2 decimal spots. If it said thousandth, how many zeros does 1,000 have in it? 3 decimal spots, right? So that's an easy way to remember decimals, okay? But that's going to be the end of today's notes. So until next time, see ya then. Peace!